Hello students, let us continue the session on revision in the chapter coordinate geometry. In previous session we had discussed till question 6. Let's move on to question 7. The area of a triangle with vertices A equal to 3, 0, B 7, 0, C 8, 4 is. We have learned a formula to find out the area of triangle. So area of triangle ABC is given by the formula half times. I have given you an hint how to write the equation. How to write the formula 1, 2, 3. Then plus 2, 3, 1. Then plus 3, 2, 1. 3, 1, 2. It goes in a cyclic order. This is the formula. Let's substitute. It is half multiplied to x1 is 3, y2 is 0, y3 is 4, plus 7, 4 and 0, plus 8, 0 and 0. This will become equal to half multiplied to, this is negative 12, positive 28, plus 0. This will become half times 16, which is 8 square units. This verifies option C is the right answer. Question number 8. The points minus 4, 0, 4, 0 and 0, 3 are the vertices of a right triangle, isosceles triangle, equilateral triangle and scalene triangle. To identify what type of triangle is the given vertices, we need sides. For convenience, I'll consider A as negative 4, 0, B as 4, 0, C as 0, 3. Let me find out the distance AB using distance formula. AB will be under root x2 minus x1, which is 4 minus of minus 4 whole square, plus 0 minus 0 whole square, and we get the length of AB as root of 64, which is 8 units. Same way, I'll find out the length of AC, which is under root 0 minus of minus 4 whole square, plus 3 minus 0 whole square. This will be root of 16 plus 9, which is 25, and root 25 is 5 units. Let me find out the length of BC. BC will be under root 0 minus 4 whole square plus 3 minus 0 whole square. It is root of 16 plus 9. Once again we have got root 25, which is 5 units. In this case we have BC equal to the length of AC equal to 5 centimeter, and another side AB is 8. Let me write it as units only, units. With this we can conclude that it is an isosceles triangle. So this verifies that option B is the right answer. It's an isosceles triangle. Question number 9. The point which divides the line segment joining the point 7 comma minus 6 and 3 comma 4 in the ratio 1:2 internally lies in the, we need to find out the coordinate of the point which is dividing the line joining these two points. Let me call this point to be A, which is x1 y1 having the coordinates 7 comma minus 6. Let me consider one more point B, which is x2 y2 having the coordinates 3 comma 4. Let there be a point P x comma y which divides this in the ratio m1 1 m2 2 1:2 ratio. We have learned by section formula the coordinate of x is given by m1 x2 plus m2 x1 divided by m1 plus m2, and coordinate of y is given by m1 y2 plus m2 y1 divided by m1 plus m2. So the value of x will be equal to 1 times 3 plus 2 times 7 divided by 1 plus 2, which is 3 plus 14 upon 3, which is 17 by 3. The y coordinate is 1 times 4 plus 2 times negative 6 divided by 1 plus 2. We have 4 negative 12 divided by 3. 4 minus 12 is negative 8 by 3. So the point P has the coordinate xy, which is 17 by 3 comma minus 8 by 3. Here the positive value and a negative value plus minus is there in which quadrant? It is there in fourth quadrant. When we look at all the quadrants, here the first quadrant both are positive, in the second quadrant negative positive, in the third quadrant both negative, in the fourth quadrant we have positive then negative. The x coordinate is positive, y coordinate is negative, therefore the right answer is option D, fourth quadrant. Question number 10. The point which lies on the perpendicular bisector of the line segment joining the points A minus 2 comma minus 5 and B 2 comma 5 is. They have given that the perpendicular bisector, so it means that point will be the midpoint of the line segment joining point A and B. The point will be midpoint of AB. When we have learned by the midpoint formula, the coordinate of midpoint as x1 plus x2 upon 2, y1 plus y2 upon 2. Let's substitute. It is negative 2 plus 2 divided by 2, negative 5 plus 5 divided by 2. Hence we get the midpoint as 0 comma 0. So the perpendicular bisector passes through 0, 0. And this verifies option A is the right answer. Question number 11. The fourth vertex D of parallelogram ABCD whose three vertices are A minus 2, 3, B 6, 7 and C 8, 3 is. We have to have a parallelogram here. It's a rough figure. It's a parallelogram ABCD. The coordinates of A is minus 2, 3. The coordinates of B is 6, 7. The coordinate of C is 8, 3. The coordinate of D is not known. Let me call this as x, y. Suppose if I join these diagonals, the point of intersection, I'll call it as O. We know that whenever we consider the diagonals of parallelogram bisect each other. Therefore, we'll be having the midpoint of diagonal AC will be same as the midpoint of diagonal BD. Their midpoints will remain same. So let's use the formula and find the midpoint. It is sum of the x coordinates by 2, that is negative 2 plus 8 divided by 2, 3 plus 3 divided by 2, which is equal to x plus 6 divided by 2, y plus 7 divided by 2. Let us further simplify. We get this as 6 by 2, which is 3. 6 by 2 is 3, 3, which is equal to x plus 6 by 2, y plus 7 by 2. On comparison, we get x plus 6 by 2 as 3. This implies that x plus 6 is equal to 6. X value is 0. And y plus 7 by 2 equal to 3. We get the value of y as 6 minus 7. So y value is negative 1. Therefore, the fourth vertex is 0, negative 1. This verifies that option B is a right answer. Let us discuss 12th question. If the point P2, 1 lies on the line segment joining the points A 4, 2 and B 8, 4, then we have to identify which of this relation will hold true. Let me mark 2 points and join them. This is point A having the vertices 4, 2. One more is point B having the vertices 8, 4. The point P is on the line segment AB, which is having the coordinate 2, 1. We do not know the ratio here. Let me mention this as m1, this as m2. By the section formula, we have the x coordinate of this point P is given by m1 x2 plus m2 x1 divided by m1 plus m2, and the coordinate y is m1 y2 plus m2 y1 divided by m1 plus m2. This implies that x coordinate is 2, which is equal to m1 x2 is 8 plus m2 x1 is 4 divided by m1 plus m2, and 1 is equal to m1 into 4 plus m2 into 2 divided by m1 plus m2. So what we obtain here upon cross multiplying, we'll be getting 2 times of m1 plus 2 times of m2 equal to 8 times m1 plus 4 times m2. When we transpose m1 to one side, we'll be getting negative 6 times m1, which is equal to positive 2 times m2. So m1 by m2 is equal to negative 2 by 6, which is equal to negative 1 by 3. Same way, when we cross multiply, we'll get m1 plus m2 equal to 4 times m1 plus 2 times m2. We get negative 3 times m1 equal to positive m2. So m1 by m2 is negative 1 by 3. So it is something like this. The point is making the ratio 1:2 like this. Point P is outside. Let me erase this part. Right. Point P is dividing the line segment externally. So only we have the ratio like this. AB from here to here it's 1 unit. From here to here it is 2 units. Together it is 3 units. The ratio AP upon PB is negative 1 by 3. AP is equal to negative 1. This means that one part outside AB. PB is 3. So the length of AB is 3x minus 1x, which is equal to 2x. So AB will be half of AB. Let me substitute here. AP length 1 equal to half of AB length is 2. So 1 is equal to 1. This is what we get. This is for verification. So this means that the relation AP is equal to half AB is a true relation. This verifies option D is the right answer. With this question, I'll end today's session. We shall take a few more questions in the next session. Thank you.